So I'm looking at problem number 8. As I was telling you, I've already went over the other stuff. I recorded videos on it. If you got questions, I'll try to get to it later. Otherwise, I'm posting it shortly. I'm posting it probably after this period. So anyway, calculate the logarithms, just like the bell work we were doing. These logarithms go back to, remember that function that we did, what power? So what power of 125 equals 5? Now remember what I told you, that if your base is bigger than the number that you're trying to get to, if your base is bigger, what did I tell you, what kind of answer are you going to have? A fraction. So I know I got a line right here. The question is, what's on top and what's on bottom? So I think about 5 to what power gives me 125? 3. That's what's going on the bottom. And then I just put a 1. Because 5 to the third power is 125. The answer is 1/3. All right. So this is like lesson 8. Lesson 8. So anyway, if I look right here for C, the log of 1 over 100, what's my base? Remember, no base means it's 10. Means the base is 10. So that's, remember, what power of 10 equals 1 over 100? I got a fraction that I'm trying to get to. I'm not starting with a fraction. What does that tell me about my answer? Not a whole number, but it's negative. If I start with the whole number and I end up with a fraction, that means my answer is going to be negative. So I know I got a negative, but a negative what? I look at the number that's my base, 10. I look at the number that I finish with, 100. How do I go from 10 to 100? 10 times 10, or 10 to the second power. So that means my answer is negative 2. Because I'm trying to get what exponent is going to give me that. The negative makes it go from a whole number to the denominator of a fraction. And then I went from 10 to 100. That's the second power. So that one's 2. This one's 1/3. This one right here, let me see if I can find 12 real quick. Didn't hear a word you said. Something like that, yeah. That's what I was saying. That's why I didn't have a problem doing the bell work, because it kind of relates to the test. I just had 12. Where the heck did 12? Ah, there we go. Okay, so right here, this problem for like the 20th time goes back to this rule right here. Oh, you know what? I'm so sorry, ma'am. You just said that, and I totally missed what you were saying. I just did this as an example while we were doing bell work. If I look at this, 4, my base is 4, and I'm trying to figure out what power of 4 is going to give me 8. It can't. 4 times 4 is 16. You can't get 8 like that. So I can't do that. So that's when I got to call on Rule 6. Rule 6 says that this 2 times my log, I can change this to the log base 4 of 8 to the second power. 8 to the second power is what? 64. So now I got log base 4 64. Now that I can do, because 4 to a certain power gives me 64. What power is that? 3. So see, that's why it's important to know that rule in particular for this situation. But you need to be able to look through your book and check these lesson summaries, because they got a bunch of rules that are going to help you. I'll probably end up listing those on the dang on the board, yeah, during the test. So that is lesson 8. 4 to the third power equals 64. So that's what I'm looking for. I've got 4, that's my base. I got 64, that's my answer. What power of 4 is going to give me 64? 3. And that's what the logs do. All right. So does anybody got any questions on these calculate the logarithms? Just like we did in the bell work there. Yeah, well, hopefully. So now, what? Nope. I'm sorry. Go ahead. Notice, Mikhail, how this log has a base of 125. This log has a base of 4. This log don't have a base at all. So it's just like what I was telling you. Mathematicians were lazy. We use the 10 as a base most of the time when we're doing logs. And so some mathematicians are like, why we always write 10? We always use 10. How about we don't write 10? And if we use in some other number, we write that number. And because mathematicians are lazy. So if there's no base, the base is 10. All right. So last call for questions on calculating the logarithms. Okay. The next thing we're going to is number 10. And crazy enough, number 10 is like less than 10 and less than 11. That's where those come from. All right. So use the logarithm table to calculate the following logarithm. This actually goes back to the number 1 and number 2 of the bell work today. So I'm going to start with 56 though. So I got log of 56. Log of 56 ain't there. But what is there is log of 7 and 8. 7 times 8 gives me 56. Does everybody understand where I'm coming from? So one of the rules of logs is right here. Number 5, property number 5, or yeah, property number 5. It says that if I have log of x times y, I can rewrite it as log of x plus log of y. So I'm going to take log of 56 and rewrite it as log of 7 times 8. Then I'm going to rewrite that as log of 7 plus log of 8. So what did that do for me? Well, if I look at the chart, guess what? I got log of 7 and log of 8. So I'm going to write those down. Log of 7 is 0.8451. And log of 8 is 0.9031. And what do? I add those two things together. So I got 0.8451 and 0.9031. I add those together and I get 2, 8, 4, 7, and 1. So my answer is, whoops, can't see it, sorry. My answer, let's move that out the way because that's confusing. All right, so my answer is 1.7482. I added those two things together. That's what I'm doing with this chart and with these numbers. So let's look at A. I got log of 2,800. I don't see no 2,800. But what I do see on there is 7 and 4 because log of 2,800 is 4 times 7 times 100. Does everybody follow me there? All right. So I'm going to rewrite this thing as log of 4 plus log of 7 plus log of 100. Now, you don't see the log of 100 up there. Yes, ma'am. Sorry. Okay, so anyway, so I got log of 4 plus log of 7 plus log of 100. If you notice, sorry, erase that. Come on, man, you're making me look bad here. All right, so log of 100 is not on my chart. But if I look at my rules, log of 10 equals R, I'm sorry, log of 10 to the R power equals R. So how the heck am I going to use that rule? Well, what is 100? 100 is 10 second power. So log of 10 to the second power is 2. So that means log of 100 is 2. Does everybody follow my logic there? If you have a number that is some power of 10, so 100, 1,000, 10,000, 100,000, a million, those numbers are just going to be whole numbers, whether they're 2, 3, 4, whatever. Because remember, with no base, the base is 10. And that's rule 3. That if I have something like that. So far I got 2 plus. So then what's next? I got 4 and 7. 4's right there, 7's right there. So I need to add those two things together. And I'm running out of room here, sorry. I got 0.6021 and 0.8451. I need to add those two things together. So I got 1 and 1, that's 2. I've got 2 and 5, that's 7. I got 0 and 4, that's 4. And then I got 6 and 8, that is 1.4. So that's 14, but I got to follow the decimal point, so the decimal point goes right there. So I got 1.4472 plus 2. So that's 2 plus all that. So my answer ends up being, erase this so I got a place for my answer. Sorry. Come on, man. Okay. So my final answer ends up being 3.4472. That's my answer. So anybody got any questions on that? I threw, yeah, because I mean, I don't have to, look, 2, I could line up my decimal points like that. And so I got 2 point blah, 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 plus 1 point blah, blah, blah. So that's 3, and then the rest of the stuff comes along for the ride. So now I got B. What's that, 40 grand? 40 G's? 40 G's definitely not up there, but 4 is. So what I'm going to do is I'm going to recognize that log of 40 G's, oops. So log of 40 G's is log of 4 times 10 grand. And what I just tell you about numbers like 10 grand, if I change it to the power of 10 that it is, and then that's my answer for my log, because that's rule 3. So 10 grand, how many zeros does 10 grand got? 4. Guess what the answer is? 4. How many zeros you got is the power of 10 that you got. So like 100's got 2 zeros, that's 2. 10 grand's got 4 zeros, so that's 4. So I know that this 10 grand right there is 4. The log of 4, well, let me rewrite this real quick. It's log of 4 plus the log of 10 grand. So we got the 10 grand, that's 4. So what's the log of 4? 0.6021. So I'm going to add 4 to that, and my answer is 4.6021. So anybody got any questions on that? Does anybody have any questions on that? All right. So the last one is 0.0003. Well, I don't got that number up there, but I do have 3. So what I'm going to do is change this to the product of, it's going to be 3 times. Now, up here, when I was multiplying my numbers by powers of 10, like 100 or 10 grand, I put those numbers there. It added zeros. This one is adding decimal places. So what do you think I'm going to have to put right here? Anybody got a clue? It's going to be a negative exponent of 10. So let's see. This is going to be, I got 1, 2, 3, 4 moves I got to make. So that's going to be, I'm dividing by, what did I say, 4 moves? So there's 1, 2, 3, 4. That's 3 times 1 over 10 grand. Now, before you flip the script and get all blah-zity-blee, let's recognize what 1 over 10 grand means. 1 over 10 grand means that we're looking at 10 to the negative 4 power. See, positive 4 means I multiply by 10. Multiplying by 10 adds zeros. A negative exponent means I'm dividing by 10, or I'm multiplying by 1 over 10. So I got 1, 2, 3, 4 moves I got to make. So that's the 4th power. So the same thing happens, just like I was doing 10 grand to where it was positive 4. because I'm doing 10 to the negative 4, or 1 over 10 grand, that's going to be minus 4. So I'm going to have log of 3 plus log of 10 to the negative 4. That is log of 3 plus a negative 4. So this last one, I took 4 and added to it. I'm a move away because I ran out of space. So I'm gonna have log of 3 plus log of 10 to the negative 4. This is gonna just be negative 4. This is gonna be 0.4771. So I got 0.4771 plus a negative 4. So that's a subtraction problem. My signs are different. It's a subtraction problem. So I need to take 4 and subtract this decimal from it. Guess I'll do it down here because I'm running out of room. 4.12345. And I'm subtracting 0.4771. I guess I didn't need that extra 0. Come on, man, erase. What the heck? There we go. Okay. So I'm trying to subtract this. I got to borrow. So I make this a 3. I make that a 10. But I'm still subtracting. So I make that a 9, make that a 10. Still subtracting. Make that a 9, make that a 10. 10. Still subtracting. So make that a 9, make that a 10. So 10 minus 1 is, then I got 9 minus 7, that's 2. 9 minus 7, that's another 2. 9 minus 4, that's 5. And then that's where my decimal point is. And then I got 3 minus 0, 3. Now, the thing to recognize is that my 4 was the negative. 4 was the negative. The positive was the decimal. So that means my answer is going to be a negative. So now I got to make some room to put the dang answer. So let's erase this. Come on, man. Okay, there you go. So the answer is going to be negative 3.5229. That's my answer for C. And let's make sure I'm circling the answer here. That was this one. Yep. So A, B, C, D. Didn't have a lot of space, but does anybody have any questions? Does anybody have any questions? Okay. I'm going to stop this recording, and this is that next part. The last thing I got to do is questions 10 and questions 11. So I think I got a few minutes that I can do something. So stop this.